another unit, namely the module 7, which deals with characterization techniques which are related to spectroscopy based techniques. So far in the previous unit we looked at characterization techniques which are related to microscopy, wherein the way we analyze using any one of the techniques, starting from optical microscope, electron microscopy, or scanning probe microscopy, we always get an image of the sample in terms of the various types of resolutions that one can get. Next, in this unit, we are looking at spectroscopy techniques. So first, we would like to see, we will consider only two types of primary radiations, namely photons and electrons. There are many other primary radiations that one can use, like neutrons, also ions, but for the purpose of the techniques that we are going to deal with in this unit, we stick to only two types of primary radiations: photons, sometimes they are also called X-rays, or electrons. And we will like to see how these primary radiations modify the matter, or how these primary radiations modify the radiation by itself gets modified, and then finally look at the secondary radiation produced, and then look at what are the different types of techniques that are based on such detection of the secondary radiation. So let us first consider photons. There can be many types of modifications or interaction of the photons with the matter. So one is that you can have elastic vibrations. Another is you have a recoil of electron, or you can have bond breaking when you are exciting with photons of a particular energy. Also, when substances absorb photon, they may also lead to ionization of the material and also de-excitation of the electrons from higher levels to the lower levels. So how does the radiation by itself get modified? Well, the radiation can either lose energy or maintain its original energy. So if it loses energy, okay, or does not much change energy, then it's called an elastic kind of scattering or quasi-elastic scattering. On the other hand, if it loses energy, it is called an inelastic scattering. So even when you have bond breaking taking place, at that time also you can have inelastic scattering on account of the absorption. So when you have an elastic scattering taking place of the radiation which impinges on a particular sample, then the type of techniques which arise from this kind of interaction are related to IR, infrared Raman, or Raman spectroscopy, or light microscopy, also X-ray diffraction techniques. When you have an inelastic scattering, then you have things like Compton spectrometry or photolithography. And when you're talking about bond breaking, then you can have techniques which are related to optical absorption or X-ray absorption spectroscopy. Then when ionization takes place, when the primary radiation ionizes a particular material, then what happens often is that there are certain photoelectrons which are generated, and these photoelectrons are ejected out of the system, and we detect these photoelectrons. So based on the detection of these photoelectrons, the technique is called X-ray photoelectron spectroscopy. X-rays, because here again we are using photons or X-rays to excite your particular material. Then there are also de-excitation of the material that can happen, and at that time also either photons are generated or secondary electrons, which are also called Auger electrons. So based on that you can have Auger spectroscopy or X-ray photoelectron spectroscopy. You can also make studies of luminescence and X-ray X-ray fluoroscopy. Okay, so this is about when the primary radiation is photons. Next we look at electrons, how they can modify the matter. Either these electrons can cause thermal vibration to the matter, or they generate something called plasmons, which are collective oscillations of electrons created at the surface. So when the electrons interact with matter causing thermal vibration, then the radiation itself can undergo either elastic or quasi-elastic scattering. When plasmons are generated, then it often leads to inelastic scattering, or there are some amount of energy loss. So based on this thermal vibration kind of interaction of the electrons with matter, you are able to do certain techniques which are related to scanning electron microscopy, transmission electron microscopy, and even electron diffraction. On the other hand, when the radiation suffers, the electrons suffer an inelastic scattering, then the type of spectroscopy technique that one can perform is called electron energy loss spectroscopy. We will look at more detail about this technique in our subsequent classes. Then another type of interaction, that modification of the matter that can take place in the electrons as primary radiation, is something called the bond breaking or the atom displacement, which is caused by sputtering. We had discussed this in our previous units, where we discussed about different types of methods of top-down and bottom-up approaches to synthesis. So whenever you are having an atom displacement or bond breaking, so that is caused, the radiation suffers inelastic scattering, or there is an absorption. So the techniques related to this are electron beam lithography. On the other hand, when it causes ionization, then you have the generation of secondary electrons, which is also used for scanning electron microscopy or energy dispersive X-ray spectroscopy. And if you have inelastic scattering with energy loss, then you again have instead of you have these EELS, which is electron energy loss spectroscopy. If you have a de-excitation taking place, then the secondary radiations generated are the X-rays or the Auger electrons. So the type of techniques which are related to this are called Auger electron spectroscopy or energy dispersive X-ray spectroscopy. So this table shows us the various types of interactions that can occur when we are considering photons interacting with matter or electrons interacting with matter. Now, generally, any type of, in all types of spectroscopic measurements, maybe be optical, UV, IR, or X-ray or electron spectroscopy, there are mainly three types of processes that take place. With absorption, which can, if the sample is small, it is called a uh,